Believe it or not, erosion can make mountains taller. Erosion removes sediments from higher elevations and deposits them to lower elevations, but it can also raise mountains in a process called isostasy. Isostasy is the state of gravitational equilibrium between Earth's crust and mantle, such that the crust floats at an elevation that depends on its thickness and density. In the late 1800s, scientists realized that most mountains have roots of rock that project into the mantle because the Earth's crust floats on top of the mantle. If mountains are to project higher into the air, they must necessarily also project deeper into the mantle, just as a bigger block of wood floating next to a smaller block must extend deeper into the water, as well as standing taller above the water. Let's think about this in terms of a floating iceberg. People say that 90% of an iceberg is hidden below the surface of the water. The reason it floats just a little bit is that the ice is only slightly less dense than water. Imagine there was an iceberg that was perfectly cylindric and was exactly 100 feet tall. 10 feet are above the water, and 90 feet are below. If you were to cut off 10% of the iceberg, it would be 90 feet tall, but the iceberg isostatically compensates or rises 9 feet, so your net loss is only 1 foot. Now imagine that instead of a straight cut, you carved the top 10 feet of your 100-foot iceberg into a cone. Instead of sinking, the iceberg would actually rise 6 feet because you've removed 2/3 of the volume off the top, but you haven't changed the total height. This is a process called isostatic uplift. Rocks behave in a similar fashion. The Earth's crust is significantly less dense than the mantle. This means that continental crust floats on top of the mantle, just like an iceberg. In the real world, erosion assists in isostatic uplift by carving the landscape. A flat plateau could sit at isostatic equilibrium for millions of years. Then the climate could change from arid to wet and stormy, carving canyons and valleys, until the original plateau is nothing more than a few ridgetops. Erosion has now removed a huge weight of rock, carrying it off to distant lowlands. Isostatic compensation will raise the ridges to new, higher elevations. Glaciers carve rock faster than wind and rain, so ice ages speed up isostatic uplift. Isostatic uplift becomes even more dramatic after an ice age because the continent becomes lighter when the huge weight of a continental glacier is lifted through melting. That's why, even though most of the world is experiencing rising sea levels, northern Canada is experiencing lowering sea levels because the continent is still rising from the melt of continental glaciers. Still, many mountain ranges don't fit this theory. The Columbia Mountains, Sierra Nevada, and even the Himalaya sit very high on the crust, without similar roots in the mantle. Due to the nature of tectonism and the melting point of various minerals, perfect isostasy is approached but rarely attained. And some regions, such as oceanic trenches and high plateaus, are not isostatically compensated. Isostasy helps us prove the idea of plate tectonics by showing that the crust floats on top of the mantle, rather than just resting on top of it. But isostasy is still a theory that needs a lot of study before we can fully understand how it works.